Hello everyone, I'm Professor K.N. Vaksure. In this lecture, we are going to study the interference in the gears. As a designer or the manufacturer of the gears, while designing the gears, every time we need to avoid the interference. Interference which causes the undercutting at the root of the tooth and which is responsible for the failure of the gear. That's why we need to avoid the interference. In this today's lecture, we are going to consider the causes of the interference. We are going to find out the minimum number of teeth on pinion and the gear to avoid the interference. Again, how we can modify the addendum to avoid the interference and different methods to avoid the interference. Interference. Interference means when involute profile comes in contact with the non-involute profile. Non-involute profile means involute profile means that profile which above the base circle. While designing the involute profile, that profile above the base circle which is the involute and profile below the base circle which is completely non-involute, which is not satisfy the condition of that involute profile. We can just try to understand this. In this case, this is the base circle where I have just drawn one profile. This is the base circle and this is the base circle and this is the profile below the base circle. Above the base circle is the involute and below the base circle is the non-involute. Okay. Again, this is the tangent to the both the circles, base circle of the pinion and the base circle of the gear. This is the again. We know that K is the point of contact between two meeting gear gets started at this point K and ends at point L. But just try to understand, if I increase the addendum circle radius of the driven gear up to this point M, okay, at this point there will be the contact between involute profile. At this point K, you will find out this is the involute profile and this is again involute profile. You will find there is a meshing between involute, there is no any interference. Up to this point also there will be no interference, but if we extend this limit and if we that point K gets started over here, that point K, and at this case what happen, this profile every time will be the involute profile, but in this case it comes in contact with the non-involute profile which is just below the base circle. At this location we will find this. Here you have to increase the addendum circle radius of this wheel, and at this location that involute profile of this which comes in contact with the non-involute profile of this gear and which causes the interference. That's why that M and N are called as the extreme limits and which are also referred as interference points. Now that O1N will be the maximum addendum circle radius for the pinion and O2M will be the maximum addendum circle radius for the gear to avoid the interference. Okay. Again, this is the definition. That means that in the phenomenon when the tip of the tooth undercuts the root on its meeting gear, then that means this part tries to dig out some material from the base which is just below the non-involute profile at this location and which causes the interference. In this next, I will just show you how that interference is occurring. Okay, this is the maximum addendum circle radius. These are the two interference points. Okay, now here we will find there is a contact between involute profile. There will be pure, that means that gear satisfies the law of gearing, and we will find there is no any interference. There will be no any interference. This is the point K. Now this is the point M again, and these two, that point of contact between two meeting gears, we start at this location at the point M. Again you will find this is the involute profile. That means again there will be no any interference. But in this case I'll just extend this addendum circle just beyond this point M. That means this will be the addendum circle radius, and in this case that addendum circle radius which comes in contact with the non-involute profile. This is the involute and this will be the non-involute profile, and it tries to dig out some material from its base or the root, and which causes the failure of the gear at this location. That's why we need to avoid the interference, because small crack on the gear which makes the very impact on its life, because gears undergoes the cyclic loading, and that small crack which deteriorate its life. Okay, now there are some conditions for the interference. If Kp, that means path of approach, is greater than the MP, this MP, then there will be the interference. That means that this Kp is just beyond this MP. Again that PL is greater than PN. Then this RA, which is RA, this is the RA max actually, RA, which is greater than this limit O2M, and that again small ra, this is the small ra, which is greater than this O1N, then there will be the interference, and you will find that causes of this interference, which causes the undercutting. Okay, again that M and N important points are the M and N are the interference points. Every time your contact must be contact between two meeting teeth must be in between these 2 points, which are the interference points. Here you will find interference may be only prevented if the addendum circle of 2 meeting gears cut the common tangent to the base circle between the point of tangential. That point of tangential are called as the interference points. Okay, now we'll study minimum number of teeth on the pinion and the gear to avoid. We'll study minimum number of teeth on the pinion in order to avoid the interference. Okay, just try to understand these diagrams. Next I will explain you. This is the base circle radius, this will be the pitch circle radius, this will be the addendum circle radius, and this will be the maximum addendum circle radius that you can take. Okay, now just consider this diagram. Okay, now we have to find out the minimum number of teeth on the pinion in order to avoid the interference. Okay, now this O1N will be the RA max, and your RA, if your RA is less than this, that means there will be no any interference. Okay, now we will find the minimum number of teeth on the pinion in order to avoid the interference. First of all, we will consider the notations. Small t and capital T are the number of teeth on the pinion and gear respectively. M is the module, R is the pitch circle radius, G is the gear ratio, which is of capital T upon small t, phi, which is the pressure angle. Again, there is one term which is the AP into M. Every time while mentioning the addendum of any gear which is mentioned in terms of module, addendum is equal to 1.25 module, addendum is equal to 0.8 module, that fraction multiplied by that module which is referred as a AP. 1.25 is the 1.25 module, 1.25 M, that means AP is equal to 1.25, addendum is equal to 0.8 M, that AP is equal to 0.8. In this way, addendum of pinion where AP is the fraction by which the standard addendum of one module for the pinion should be multiplied in order to avoid the interference. Now just consider this triangle. Now just consider the geometry O1 P and again this total angle, this is of right angle 90, this is of phi. Okay, now just consider this triangle. O1 n square is equal to O1 p square plus pn square minus 2 into O1p, 2 into O1p into pn into cos of this angle, that total angle is of, which is the O1pn, which is of 90 plus phi. Again O1p is equal to p, which is the p circle radius of the pinion. Again just consider this triangle O2 and P. This is again one right angle triangle. Here we have to calculate this Pn, that Pn is equal to R, that Pn is equal to R sin phi. Okay, now by putting all these values you will find that equation which is of O1 n square is equal to R square plus capital R square sin square phi minus 2R capital R sin phi cos of 90 plus phi. Again cos 90 plus phi, which is of minus sin phi. That's why this equation becomes R square plus small capital R square sin square phi plus 2R sin square phi. Okay, now I will just take that R square as a common term. We'll find 1 plus R square sin square phi. We'll find this term, total term. Okay, again in this also I will just take that capital R upon small r as a common term. We'll find that R plus 2 into sin square phi. Again the limiting addendum circle radius of the pinion, which is of O1 n, is equal to square root of this total term, square root of this total term, which is of R into square root of this. Again capital R, okay, again before that O1 n is equal to, again this small r is equal to m into t upon 2 into square root of this term. I have just replaced this r by the m into t by 2. Okay, and this r I have replaced by the capital T upon small t, which is the gear ratio. Capital R upon small r is equal to capital T upon small t is equal to G. Okay, I have just replaced this R upon R is equal to capital T upon small t. Okay, now addendum is equal to addendum circle radius minus p circle radius. Addendum is equal to addendum circle radius minus p circle radius. Now O1n is the addendum circle radius and O1p, which is the pitch circle radius, and we will get the total addendum. This is the total addendum. Okay, now that AP into M is equal to O1n, just consider this equation, O1n minus O1p, which is the radius, which is of m into t by 2, that we already mentioned over here. Okay, now I'll again take this mt by 2 as a common term. We'll find this in the curly bracket, that AP into M is equal to m into t by 2 into this total equation. Again mm gets cancelled. We'll find this AP is equal to t by 2 into bracket square root of 1 plus capital T upon small t into bracket capital T upon small t plus 2 into sin square phi minus 1. This is the addendum which is multiplied by the module to avoid the interference. Okay, that means we, by changing the addendum circle radius, we can avoid the or by decreasing the addendum circle radius we can avoid the interference, and that value, how up to what limit we can reduce, that value will get by using this AP, that value which is the AP. Okay. Again, by rearranging this equation we will find out the T, that T is equal to 2 into AP upon square root of 1 plus capital T upon small t into bracket capital T upon small t plus 2 into sin square phi minus 1. Again, that capital T upon small t is equal to G, which is the gear ratio. In this way, you will find out the equation of minimum number of teeth on the pinion to avoid the interference. This is the final equation. Now let us see the minimum number of teeth on the gear to avoid the interference. Here, capital T is the minimum number of teeth on gear to avoid the interference. Again, Ag is the fraction which is multiplied by the module to get the addendum. Addendum is equal to addendum circle radius minus pitch circle radius. Now consider this geometry. In this geometry, this O2P is the pitch circle radius of the gear. This total angle O2P M, which is of this angle is of 90, and this is of phi, which is the 90 plus phi. This is the addendum circle radius, maximum addendum circle radius that we can take. Okay. Now just consider this triangle O2MP, which is of O2M square is equal to O2P square plus PM square minus O2P into PM into cos of 90 plus phi. Okay. Again, in this case, that PM is equal to PM. Just consider this right angle triangle now to find out this PM. Just this right angle triangle. In this right angle triangle, O1 PM, this is the right angle, and that PM is equal to small r sin phi. By putting all these values, just like your previous condition of pinion, you will get this equation. Capital T is equal to Ag upon square root of 1 plus small t upon capital T into bracket small t upon capital T plus 2 into sin square phi. Here, small t upon capital T, which is of reciprocal of the gear ratio. Okay, and we'll get this minimum number of teeth to avoid the interference on pinion is equal to small t is equal to 2 into AP upon square root of 1 plus G into G plus 2 into sin square phi minus 1. Again, for the wheel or the gear, this is for the gear. Just consider this as a gear. Sometimes that gear is also referred as a wheel. Okay. Twice Ag upon square root of 1 plus 1 upon G into bracket 1 upon G plus 2 into sin square phi minus 1. Now, there are methods to avoid the interference. First one is use large pressure angle to avoid the interference. See, having larger pressure angle which results in the smaller base circle. As a result, more of the tooth profiles becomes the involute, and the tip of the tooth of the one gear will not have the chance to contact with the flank. This is again very important, and which causes, that means there is very least chances of contact between involute profile and the non-involute profile. That's why use of larger pressure angle, which can, with the help of this, we can avoid the interference. Second, undercutting of the tooth. A portion of the tooth below the base circle, we have to cut off some part of. While designing we have make the provision in such a way that we design in such a way that we can undercut the tooth, so that the tip of the one tooth of the gear will not come in contact with the non-involute portion of the tooth of the other gear. Hence, we can avoid the interference. Again, by tooth stubbing. In this process, the tip of the tooth is removed. Thus, there is no any contact between involute profile and the non-involute profile. With the help of this also we can avoid the interference. Again, the increasing the number of teeth, which reduces the chances of the interference. That means, okay. Again, last one is the increasing this slight center distance. That means by increasing the center distance between two meeting teeth, that addendum circle of the driven gear, which cuts the common normal just above the M, or in between of M and N, which are the interference point, which is with the help of this we can avoid the interference. Now we'll see the minimum number of teeth on pinion for involute rack in order to avoid the interference. That means we'll find out the minimum number of teeth on the pinion in case of rack and pinion type of gears. Okay. Again, in this case, that small t is the minimum number of teeth on the pinion. R is the pitch circle radius, which is of m into t by 2. 5 will be the pressure angle. Again, this is the term AR into M. Addendum for the rack. This is the addendum for the rack, which is the AR is the fraction multiplied by the standard addendum of one module for which rack is to be multiplied. Okay. Now just consider this diagram. This is the rack, and this is the pinion. That this is the pitch circle and this is the pitch line, which are tangent to each other, and the line of contact between two meeting teeth, which is moving along this common normal. This is the common normal. Okay. This is the one your interference limit, which is the M, and here we have to find out this LH, which is this LH is the addendum of the rack. How much will be the maximum addendum we can take, that we have to find out over here. Okay, I just drawn this. This is the addendum circle radius. This is the pitch circle radius. Again, this is the base circle radius, inner circle, which is the base circle radius. I'll just construct this geometry again. Here we have to consider two triangles. Now triangle LHP, this is the right angle triangle, that LP is equal to, LH is equal to PL sin phi, and that addendum of the rack, this is the LH is the addendum of the rack, which is the AR into M, and LH is equal to PL sin phi. Now just consider this triangle OPL, where PL is equal to OP sin phi. PL is equal to OP sin phi, and that OP is equal to pitch circle radius. Okay. Now by putting this PL value, in this equation, you will get LH is equal to OP into sin square phi, and that LH is equal to AR into M, which is the addendum of your rack. Again, OP is equal to R. Again, as R is equal to M into T by 2, that means this equation becomes AR into M is equal to M into T by 2 into sin square phi. MM gets cancelled, and that will get that by rearranging the terms, that T is equal to 2AR upon sin square phi. This is the equation of minimum number of teeth on a pinion for involute rack in order to avoid the interference. Okay, these are some standard table for the addendum and dedendum. You will find, I'll just For the 14.5 degrees composite or full depth involute system, 20 degree and 20 degrees. These are the different standard gear systems. Addendum, which is of one module. Again, addendum of which is of 1.25 module. For the 14.5 degrees composite or full depth involute teeth, again you will find that one module, that one is the, if it is the pinion, AP is the one addendum. One thing that you have noticed over here, that addendum which is always larger than the addendum. This is this care that we have to take to avoid the interference. To avoid the interference, that addendum is always larger than the addendum which is always larger than the addendum. Okay, these are the some standard systems. Okay, again for the to avoid, that means minimum number of teeth on this 14.5 degree composite, again full depth involute. These are the some standard system that you have to consider to avoid the interference. That means if that pressure angle is of 14.5 degrees, every time their number of teeth should be equal to or greater than the 12, just like this. For the 14.5 full depth involute, 32 or greater than 32. For 20 degrees full depth involute, 18 or more than 18. These are the minimum number of teeth. You can take the more than this to avoid the interference. With this, what we learn? We learn the interference. We learn the methods to avoid the interference. We have found out the addendum and the addendum circle radius and the number of teeth on the pinion and the gear to avoid the interference. Again, we have considered the rack and pinion, where we have studied we have found out the addendum fraction multiplied by the addendum to avoid the interference, and minimum number of teeth on the pinion to avoid the interference. Again, we have considered the standard systems with which, while designing the gears, we have to consider the that standards and we have to manufacture that gear. Thank you for your patience listening. Thank you.